Alrighty, boys, girls, ladies and gentlemen, and everybody else, welcome to video lesson 11-3, our third lesson on area. This section we will study the area of circles, segments, and sectors. Alrighty. Okay, we already derived this in class, or we will if we have not yet, but we know the area of a circle, and you know this way back from elementary school. The area of a circle is pi r squared. And now we're going to talk about the area of a sector. A sector is like a piece of pie, a piece of the pie, or a piece of the pizza. So this red right here, this red shaded area, that would be the area of my sector. That would be my sector, and we can see it's a part of the pizza. It's a fraction of the total pizza. So we're going to find that area by taking my central angle, which is right here, which is going to be equivalent to the measure of the arc as well. We're going to take that angle, or that measure, so we'll call that measure theta, or my angle, over 360. That's the fraction of the total circle, so times the total area of the circle, which is pi r squared. So if I want to find the area of this sector right here, I'm talking about this piece of pizza right here, so this piece of my pie, this piece of my pizza, it's 1/4 of the total pizza. We can see that. We can see if I wanted to, I could chop my pizza up into fourths, and I see that this is 1/4. And I know it's 1/4 because my central angle, that's this angle right here, that's a right angle, which means now my central angle is going to be 90. So my formula is x over 360 times pi times my radius squared. Well, in this case, my angle is 90 over 360. That reduces to 1/4. And that's why I know it's 1/4 of my circle, times pi, times my radius, which is 6 squared. 6 squared is 36, so I have 1/4 times 36 pi. The 36 and the 4 can cancel, and my final answer is going to be 9 pi. Okay, let's find the area of this sector right here. We know our formula is going to be my central angle, or theta, or x, over 360, my total circle, times the area of the circle, pi r squared. In this case, my central angle is 135 over 360. That reduces, I can factor out a 45 from both top and bottom, so that becomes 3/8 times pi times my radius, which in this case is 8. 8 squared is 64. I can cancel the 8 with the 64 and get 8, and I'm left with 24 pi. And there's my final answer. Before I go on, though, I just want to show you, we had that fraction of 3/8. I know that this sector right here is going to be 3/8 of my total piece of pizza, or my total pizza. And you can see that. Let me just chop this up here for a minute. You can see now if I chop my pizza up into 8 pieces, there's 4. And there's 8 pieces now. My sector includes 1, 2, 3 out of a total 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. So you can see now that sure enough, my sector was 3/8 of my pizza, which is the same as 135 out of 360. Okay, you guys try this one right now. Find the area of that sector. You can do it in terms of pi, like I've been doing before. Go ahead and stop the tape and give it a go. Okay, you should have found you had 18 pi as your final answer. How I got that is I used my formula, central angle over 360 times pi r squared. You can see my central angle is 20. 20 over 360 reduces to 1/18. In this case, coincidentally, my radius was 18, so it's 1/18 times 18 squared. One of those 18s are going to cancel right here, so I'm just left with 18 times pi, or 18 pi, and that's the area of my sector. Okay, let's talk about another piece of my circle. It's called the segment. The segment of the circle is going to be right here, this piece right here. Okay, it's just like it's a little like piece of crust on our pizza. Okay, so if I could color in that, I could shade in red here my actual segment. Okay, a couple more words I can show you here. A chord. The chord of a circle is any line segment joining 2 points on a circle. So this line right here is a chord. Sometimes we call it a chord. The chord goes from edge to edge of a circle. There's one very special chord in the circle called the diameter. It, of course, goes from edge to edge, passing through the center. But any line drawn in the circle from edge to edge, not necessarily passing through the center, is called the chord. Okay, so let's find the area of this segment right here. So we're going to find the area of this segment right here. That's this piece of crust. We're going to find that by, first of all, by finding the area of the sector. That's this sector right here. And then we're going to subtract the area of the triangle. And you can see that this is the area of my triangle right here. Okay, so we're going to find the area of my sector first. We'll do that back in red. I know that's going to be my central angle, 90 over 360, times pi, which is pi, times my radius squared, which is 2 times 2. So this is 90 over 360 is 1/4, times 2 squared, which is 4, times pi. 1/4 times 4 pi is pi. So I know that this whole area of my sector is pi. Now the area of my triangle, of course, is 1/2. In this case, base times height. In this case, my base is 2. It's a radius. And my height is also 2. It is a radius. That's convenient. So my triangle, the area of my triangle is 1/2 times 2, which is 1. 1 times 2 is 2. So this area is 2. My final answer is going to be, and I'll write that in green, pi minus 2. Or if you want to write it as a decimal, it's going to be 3.14 minus 2, which is 1.14. And there are my answers. All right, let's find the area of this segment right here. My segment's going to be right here in green. It's a big piece of pizza crust. Big piece of pizza crust. So there's my segment. And again, we're going to do that by finding the area of the sector, the ice cream cone, minus the triangle part. We already found the area of this sector once. I'll just write it again for you real quick. We found this in the beginning. It's going to be 135 over 360, which reduces to 3/8, times pi times my radius squared, which of course is 8 squared, which is 64. The 8 and the 64 cancel. That gives me 3 times 8, which is 24 pi. So the area of my sector is 24 pi, minus the area of my triangle, which is going to be 1/2 base times height. We'll do that over here to the side in red, 1/2 base times height. My base, we can see, is a radius, which is 8. 1/2 is 1/2. And now let's look at the height. Do you see, I'll do this in yellow, do we see we have a right triangle right here? That's a 45-90 right triangle, because this is 135, which means this guy right here must be 45, which means that guy is 45. This right here, the hypotenuse is 8. So each of these legs are going to be 4√2, which means most importantly now my height is 4√2. So the height is 4√2. So the area of my triangle is 1/2 times 8, which is 4. 4 times 4 is 16√2. So I can write that right here. That could be your final answer if you want. If I ask it as a decimal, your answer is going to be, I'm pulling out my calculator, 24 times 3.14 minus 16 times √2, equals, it's approximately 83.7. Okay, one more problem here, or actually two more, but one more we'll do together. Let's find the area of the shaded region. So we're going to find the area of this shaded region. And this is what we call a composite figure. In other words, you're going to have to figure out the area. There is no formula for the area of this shape. Okay, but all it is, as I'm hoping you can see, it's the area of a rectangle minus the area of two circles. If that makes sense, it's the area of the rectangle, which is right here, minus the area of this circle and this circle. So the rectangle is 6 by 12. Well, let me get my marker back. 6 by 12. So the area of the rectangle is 72, 6 times 12, minus the area of the circles, which of course is 2 pi r squared. In this case, the circles, the radius is going to be 3. Each of those have a radius of 3. So my radius is 3. Pi is pi. 3 squared is 9. So I have 72 minus 2 times 9 is 18, 18 pi. You can leave your answer right like that if you'd like. If I ask it for a decimal, you're going to do the 72 minus 18 pi, which equals 15.48. Okay, why don't you guys try this one? In fact, the first 5 people that email me a correct answer on this one, a correct answer, get a bonus point on your next test or quiz. I want to find the area of the shaded region. That's going to be this right here, this shaded little swerve. Let me give you a clue. You got a big circle. You're actually going to have a medium-sized circle, and you're going to have a little circle. So you're going to have to add and subtract some circles here to come up with the area of this shaded region. Give it a go, and the first 5 people to email me your answer get a bonus point.